Hello, this is Mrs. Bellotti. I am going to go ahead and walk you through 9.2 pre-assessment number 1. Right now, our focus is going to be on the first 3 questions. That's really focused in on the basics of stoichiometry. The before, change, and after tables, we call them BCA tables, are vital for you to completely understand what is occurring in a chemical reaction. And it's so important for you to be able to understand that to predict what your products should be. So let's go ahead and walk through this. Question number 1 gives us the balanced chemical equation. That is always the first step with a stoichiometry question. If it's not given, if the balanced chemical equation is not given, you have to determine it. But we already have it. We see here that we have a 2:4:3 ratio in our balanced chemical equation. So that's a 2:4:3 relationship. What is our question asking though? Let's take a look at that. What is the mole ratio of aluminum to oxygen? That is what we are looking at. So we've got aluminum and we've got oxygen. Remember, oxygen is diatomic. Well, our balanced chemical equation says for every 2 moles of aluminum oxide, we produce 4 moles of aluminum and 3 moles of oxygen. So our ratio of aluminum to oxygen is a 4:3 ratio. Question number 2. Let's look at the question. What mass of chlorine gas is required to react with 2 moles of sodium? Okay, mass is grams. Chlorine gas. Chlorine is diatomic. And this is what we're given. Now looking at, once again, our balanced chemical equation, we see there is a 2:1:2 relationship. For every 2 moles of sodium, we require 1 mole of chlorine gas to produce 2 moles of sodium chloride. Now, we are really lucky here, let me point out, that our given happens to be 2 moles of sodium, right? It correlates with our balanced chemical equation. So what's our answer? Well, 1 mole of chlorine gas is required. But this is not the correct answer. We have to convert this to grams. Grams is the macroscopic scale. The way we convert from moles to grams is looking at our periodic table. If I look at my periodic table, I look up chlorine, there are 35.45 grams in every 1 mole of chlorine. Now, remember, we're dealing with a diatomic element. So we actually have Cl2. So easy, we just multiply this by 2. We have 70.9 grams in every 1 mole of chlorine gas. And we determined that we needed 1 mole for our reaction. So this is our answer. The BCA tables, I've mentioned them before, will help you completely understand what's happening in every step of the reaction and help you figure out how much you can theoretically produce. So let's take a look at what we have. We need to determine the moles of nitrogen required to produce 12 moles of NH3. So this is our given amount. Let's go ahead and put that in. We need 12 moles to be produced. So we will automatically start off with no product. Beginning of a reaction, the before, there will not be any product. So the products will always be 0. We will have to create 12 moles of this material so that we can have our required product. Okay, so let's break this down. Based on, again, we have a balanced chemical reaction. For every 1 mole of N2, we need 3 moles of H2 or hydrogen gas and nitrogen gas, we will produce 2 moles of nitrogen trihydride, and that's ammonia. We have a 1:3:2 ratio. Some of you at this point can do parts of this in your head when it's basic ratios, but I'm going to go ahead and show you the math. I recommend always doing the math just to make sure you understand what you're looking at. Okay, our first relationship we're looking at, we need to figure out how much nitrogen is needed to produce our 12 moles of ammonia. Okay, so we have 1 mole of nitrogen gas for every 2 moles of ammonia produced. That ratio will always be the same. So if I know I need 12 moles of ammonia, I can solve for my unknown x. Now at this point, you just cross multiply, divide, and solve for x. I solved that I need 6 moles of ammonia. Again, some of you may have done that in your head. That is okay. We have to start with 6 moles of, not ammonia. It was nitrogen. Okay, so we needed 6 moles. We're going to use up all 6 moles to produce our product. We're not going to have anything left. Okay, let's go ahead and take a look at hydrogen. Okay, so here's our hydrogen. It's not necessarily in the question. Why do we need to do these calculations? They seem to be extra, but they're not. To really understand how a chemical process occurs, you need to know all of the information. You need to know exactly what is going to be produced, how much you need. So in this situation, we'll go ahead and work with the NH3, the ammonia, because that was given in the question. We know that we have 3 moles of hydrogen gas needed to produce every 2 moles of ammonia. Okay, again, we produce 12 moles of our product. Let's solve for x. All right, so 36 divided by 2, you can calculate that out. We need 18 moles of hydrogen gas for this reaction to occur. We'll use it all and be left with 0 of our reactants. All right, I am going to leave number 4 up to you to try to work through. I know some of you are having trouble getting number 3 and number 4 to load in your browsers. That is a Canvas glitch that we are unable to fix. So try it on a different laptop. See if you can get it to load. Remember, you've got multiple attempts at this. It's always good to do these on scrap paper in case you have to try it again and take notes and resubmit it. Good luck. I hope this helps you.